What's up, everybody? It's your boy Malik. I got another video for y'all today. As y'all do know, my channel consists of, heating and air conditioning, automotive technology, cars and stuff like that. But with it being cold and with it starting to get cold outside, I wanted to do a video on something. Actually, this is going to be a series. The video I'm doing today is what is a heat pump and how do they work? My next video is going to be probably something along the lines of, I guess I want to say dual fuel. What are the advantages of a dual fuel? And then the video after that is going to be, at what point should you consider getting a higher efficient unit? What are the advantages of having something like an inverter heat pump versus a single stage or a two-stage heat pump? Because when a guy comes to your house, the air conditioning man, the person who fixes your heat or installs your heat, and he lays out on the table some options. It's not going to be your best advantage to go with something like lower end nowadays, because with the type of weather we're starting to have, it's starting to get colder. The weather's starting to get more frigid. It's starting to get, and in the summertime it starts to get more humid and stuff like that. So I'll go in detail about that in my next couple videos. But today we're going to talk about what is a heat pump and how do they work. I done a video on the defrost cycle on a heat pump, but I didn't really go into detail with how a heat pump actually works. So the example we have today is a Bryant system. Bryant is made by Carrier, Heil, ICP, International Comfort Products. That group, Payne, all those are the same people. So, it's not necessarily the exact same shell, but it has a lot of the same internals. I'm going to talk about my system in particular. This is at my house, my personal house, and I actually put this unit in myself. I had a little bit of assistance, but I, practically put this in myself. And then to the right of me is the system that it replaced. But I'm going to talk about how heat pump works today, and how exactly they do it, and the tier of systems you can get to where they can do it a lot better. So we're going to dive in. This is in Bryant Evolution. This is going to go by a SEER rating. This is an 18 SEER. SEER stands for Seasonal Energy Efficiency Rating. So the higher that SEER is, the less it takes to operate this unit. The more it saves you, the more heat it can absorb from outside and dump in the house without pulling as much power. Basically the higher the SEER, the higher efficiency the unit is. So I'm gonna dive in and talk about this one in particular, and we're gonna learn just a little bit of information today. Before we start, I want to start with what I took out of my house. What I took out of my house was a straight AC and a gas furnace. As you can see, this is not a heat pump. I've actually taken this unit out of my house. My unit actually wasn't even on the back of my house. All this stuff, none of this even existed. I mean, the pad wasn't there, the line set wasn't there. The drain was there, but when I bought this house, it was draining under my house. I actually had to run the drain. I run a whole new drain outside. That box wasn't there. The surge protector was there. This was there. The unit was actually on the other side of my house, right up under my window. And this thing was a loud little bastard right here. I mean, this thing, when it kicked on, my boy, it surged the lights, it vibrated the wall. And this furnace right here done the same thing. What do I mean by straight AC? What I mean by straight AC is the only time the outdoor unit is running is when it's cool in the house. This was not a heat pump. To heat my house, I use the gas furnace. I'm going to talk a little bit more about my particular setup I have here in a different video. What I have today is, like I said, it's a Bryant Evolution 18 series. Now, this is a 3-ton system. So, depending on what capacity system you get, it's going to dictate how big or how wide or how tall the outdoor unit is. This system right here is a variable speed system. It's an inverter system. What does inverter mean? Inverter means that this unit doesn't just turn on and off. It has multiple stages. It can vary its capacity. So yes, it's a 3-ton, but depending on the demands of what I need inside my house, depending on the weather outside, because this unit, a system like this, it actually does kind of collab with the local weather, and it does read the humidity inside the house. So it tells it what stage to run or how fast it needs to run. Basically what a heat pump does, okay, if you have a gas heating system and you don't have a heat pump, your outdoor unit doesn't run. With a heat pump, your outdoor unit does run. Now, when I'm gonna say this next part, you're gonna think, oh, it runs backwards. No, the way a heat pump works is it takes the outdoor unit and it runs it, but it sends the refrigerant the opposite way. So basically, it's reversing the flow of refrigerant. So the fan still spins the direction it's supposed to turn. The compressor still spins the direction it's supposed to turn. But the only difference is the refrigerant is now being sent, the hot refrigerant is now being sent inside. So in the summertime, when you understand in cooling mode, you're used to seeing this run and you can wave your hand over it or walk by it, and it's actually going to be blowing out air warmer than what it is outside. So the way this works, all right, that reversing valve, you can't see it, but it is right down there. You know what? I'm gonna try this. If you look right there, you see that right there? That little bronze piece right there, not the copper, the bronze piece right there, that's got the pink sticker on it and the orange on it, that is your reversing valve. All right, basically what that does is it's operated by a magnetic solenoid. All right, and when triggered, it's basically inside, it slides the other way. So you've got these little tubes in there, and the reversing valve basically rocks like this. It slides this way or slides that way, and it allows refrigerant to travel in this hole and in this hole, or in this hole and in this hole. When it does that, the refrigerant, either the hot refrigerant is either being sent here or being sent to the air handler or the coil or wherever your system is, whether it's under the house or in the attic. Basically, the unit still operates like it's supposed to. Like I said, that reversing valve dictates whether you're going to be absorbing heat or rejecting it. Now, in the cooling mode, you are rejecting heat outside. This is what they call a condenser, but you don't call this a condenser when it's a heat pump. You call it just a coil. I mean, basically, that's all it is. If you have just a straight AC, that is a condenser and it never changes. It is always a condenser. But a heat pump, this can be called the evaporator. So the evaporator coil is the one that's cold and it condensates, and it's always going to be cold. It's never going to be warm. It's never going to be hot. When you turn this into the heat mode at your thermostat, all you do is turn it on heat. Your inside unit becomes the condenser, because that's the one that's hot. That's the one that's going to be rejecting any heat that's already in the house, and it's going to be adding more heat to the house. Basically, this is adding heat to outside. Think of it this way. This is adding heat to outside, because it's always going to blow air out warmer than the air that is around it. You know what I'm saying? So in this case, this system here in particular, it decides what it needs to do. So you turn it on heat mode, and the board behind here, this is what you call a, I guess you could say, if for a traditional system, behind this panel right here is going to be what they call a defrost control board. The defrost control board overrides just about any setting you put it on in heat mode. What I mean by that is your defrost control board will dictate how often the strip heaters come on, and it dictates when this unit needs to switch itself back over. When you have a heat pump, you have what's called a defrost cycle. You have sensors on this coil, and that's another thing. You have sensors on this outdoor unit that basically tell it, because when you're trying to absorb heat from outside, think of it this way. It's 20 and 30 degrees, 10 and 5 degrees outside. To absorb heat, you have to bring the temperature of this outdoor unit or this evaporator coil below, because that's the same thing it does in the summertime when you're trying to cool the house off. You can't cool the house off if the evaporator coil is the same temperature or close to the same temperature as what's inside. It's never going to work. So it's basically absorbing heat from inside and dumping it outside. But now you're trying to absorb heat from outside and then pump it inside. So it's the same concept. This will start condensating. You will see water dripping off of it. You might walk out here and see ice on this thing. And that's another thing. So if it's 20 degrees outside, well, anything below 32 degrees or 32 degrees or below is what they call freezing. That's freeze point for water, depending on the atmospheric level. 32 degrees is freeze point for water, all right? If 32 degrees is freeze point, well, let's talk about it like this way. I know it kind of confuses people when they hear it go into defrost mode and it's 40 degrees outside. Very possible, because if it's 40 and this is operating at 20 or 25 or 30, it's going to go into defrost mode. It can be 45 degrees outside and your heat pump will go into defrost mode. And it might not be as long as it will as if it's 20 degrees outside, but last night it was about 20 degrees. Now, I'm not going to say I could particularly hear this thing going to defrost, but I can hear when it was switching over. My unit in particular is a dual fuel. I'll talk about that later. But this one in particular, when it went into defrost, the colder it is, we all know the less efficient the heat pump gets. So when it's colder, the colder it gets outside, the more frequent you're going to have defrost cycles, the harder it is for it to work. Like, it's going to have to work harder, and the longer run times it's going to have. And if you have an all-electric heat pump and you don't have a dual fuel, I keep saying the word dual fuel. Think of it as this way. Instead of having an electric backup heat, my backup heat is gas. I'll talk about that later. Basically what happens is when this goes into defrost, whatever your source of backup heat is, whether it's gas or electric, the defrost board is going to mandatorily turn on that backup heat. Now, the reason it does that is because defrost mode is cooling mode. Defrost mode is air conditioning mode. All right. Now it's 20 degrees outside and you've got cold refrigerant going inside. Well, you could be undoing what you just did, what it just took an hour to do, what it just took 30 minutes to do. If it took it 30 minutes just to bring the temperature up 2 degrees, or an hour just to bring the temperature up 2 degrees, if you're sitting cold refrigerant there, you're going to undo that and some, because it doesn't take long. I mean, if it's 20 degrees outside, the coil only has to operate at about 40 or 50 degrees to reject heat. So now you're taking that refrigerant's absorbing how cold it is outside, and it's rejecting any heat that's outside, and now it's sending that cold back inside. You don't want to do that. You don't want to do that. You don't want to do that. So when it goes into defrost, the first thing that happens, the outdoor fan stops. It turns off. You'll hear the compressor running. You'll see steam flying off of it. I mean, it will be putting on a steam show. I mean, you don't need a smoke machine when you have a heat pump. You got one in your backyard or on the side of the house or wherever it's at. All right. Now, I'm going to power this thing up. While I'm talking, you're going to hear this thing get faster and faster and faster because it's a variable speed heat pump. These heat pumps that are variable speed are so much more efficient than just a single stage unit that I will never invest in another single stage. If I buy a house and it has a single stage, I don't care if the unit's 2 years old. I'm ripping it out and I'm putting a variable speed unit in there. Because let me tell you something, there is no better advantage than having something that does not run full speed all the time. This unit right here, when it's running, it only pulls 4 amps in the lower stages, 4 to 6 amps. The most amps this thing pulls is 12. That thing right there that I took out was pulling 21 in the heat of the summer, 21 amps. All right, that's just about the same amps as a dryer. So, yeah. If you can't tell, this unit is running right now. Listen. All right, the first thing you're gonna see on a Bryant system, the fan's gonna do a dance like that. Everything about this unit is variable speed. There is not a single motor on this unit that does not have multiple speeds. All right, you're not used to hearing something that quiet. You're used to hearing a listen. That's the only thing you will ever hear is the fan motor make that. That is literally, I can be sitting in my house and I can barely even hear that sometimes. All right. While I'm talking, this unit is going to constantly be speeding itself up. It's speeding itself up right now. All right, for the first couple minutes that it runs, it's gonna warm itself up. You know what I'm saying? Because if it just jumped straight to full speed, it would probably tear itself up. All right, it constantly stages itself up, and the reason it does it in increments is because it may satisfy its set point before it even reaches its fifth stage. It tries its absolute best to stay away from its fifth stage. This one in particular, the 18 SEER, is a 5-stage system. Now they have a 20 SEER and they're coming out with a SEER higher than that. The 20 SEER has 60 stages, but an inverter in particular, it doesn't matter how many stages it have. If it's variable speed, it's variable speed. You'll hear people say 3-stage, 2-stage. Those are not variable speed units. Those are multi-stage. Variable speed and multi-stage are not the same thing. Anytime the word inverter is involved, it's variable speed. So while this is staging up, my system that's under the house will also be staging up. It is also variable speed. And even while it's speeding up, you can't hear it. I mean, you can hear the, but that's about it. When I tell you that air coming out of the fan is so cold, it's choking me up. All right, I'm gonna open the door so we can hear the full thing speeding up. All right, so as you can see here, this is what basically almost drives this. And this is the inverter drive. When you have a control board that is this big and this sophisticated, and you've got indicator lights on it, you've got diagnostic lights on it, this is my inverter control. This unit cannot run without this. You cannot force this unit to run without this. This is for more primarily for the technicians. All right, you've got all this stuff on this board, and absolutely nothing is possible without that little chip right there. You see that chip right there? That is what makes this unit realize who it is, what capacity it is, how many stages it has. That tells this unit what to do. All right, now, different than a traditional heat and air conditioning system, this is what they call a communicating system. So this system is able to self-diagnose itself. It goes through self-test. It tells you when to change the filter. It tells you anytime the unit goes fault, like if it faults out, it basically tells you everything. And it sends it to the thermostat, which in this case is called a Connex controller for Bryant. And I don't even think it's reached its 5th stage yet. Or either it has, or I'm not used to how quiet it is. I literally listen to this thing every single day. All right, you've got all these sensors and controls and wire harnesses, and a traditional system would have more than just 4 wires. This system communicates through only 4 wires. So communicating is by small millivolts, whereas a traditional system is sending 24-volt signals to it, and it's telling certain relays to come on. Like it doesn't know what it's telling to come on. It's just saying, hey, I'm gonna take this one and I'm gonna touch it here, and then this is gonna make that come on. No, this system communicates. You don't hear any relays clicking. There is no, you don't hear that come on. There's no contactor. There's no, I mean, this thing does not have any relays on it. I mean, it does, but it's not the traditional relays that are on a traditional system like that right there. This system right here, all right, you've got a contactor, and that's about it. This one right here, you've got contactors, you've got capacitors. I'm sure we've all had to replace capacitors before. I'm sure we've always had to have a contactor replaced before. There's none of that on an inverter system. So that eliminates how much maintenance you would have to do on the electrical side. I mean, literally, when I go do a maintenance on these systems, I run it through a self-test, I clean it, I check the charge on it, and I don't touch anything else because there's nothing else to touch. You don't have, anytime something goes wrong with this system electrically, that entire board has to be replaced. You can replace a sensor or something like that. You can replace the fan motor, the blade, and stuff like that, yes, but there's no capacitors, there's no contactors. This is one entire piece. If this board goes bad, the entire piece comes off, and it is shielded because inverter takes AC voltage, which is being fed from your power company, and it converts it or inverts it, as you can see right there. It inverts it to DC voltage. and it steps it up a lot higher. I mean, if you think being shocked by AC voltage is bad, get shocked by an inverter board, and you probably won't live to tell anybody about it. I'm serious. But now I can go get my amp meter right now and show you the difference between an inverter's heat pump and a regular heat pump. Like I said, a regular heat pump's gonna pull anywhere from 18, 15 to 20 amps. This system right here has never reached anything above 15 amps. $12 amps. I mean, that's less amps than a dryer. That's less amps than an oven. That's less amps than the system that you're used to. I mean, that old heat pump that you hadn't replaced, that's 15 years old, and it flickers the lights every time it comes on. Now, this is only when it's running 5th stage. And this unit barely ever runs 5th stage unless I've got it. Like, say I come home and it was 70 degrees in my house and I bumped it up to 74, well, that's a 4-degree gap, so it's gonna run 5th stage. But if I've got it on set to 74 and it's 72 or 73, it's more primarily gonna be running 3rd or 4th stage. So I'm gonna try to slow this thing down by, you know, closing the gap on the temperature, and we're gonna see where this unit actually would be sitting at. All right, so now, as you can see, the system has slowed itself down, right? Okay, if I can get it to focus on this. That's 3.75 amps. This is when the unit is running its 1st stage right now. So it has slowed itself down to, it's getting dark in here, I know. But it has slowed itself down to the point where you can't hear it. You can't even tell it's running. I mean, just listen. More than likely, this unit is going to be sitting between 1st and 3rd stage when it's running. Right now, this unit is pulling again 3.2 amps. That's less amps than, I don't even know what to say. I mean, if I can get it to focus again, 3.1 amps. 3 amps. All right. $2.9 amps. I mean, this entire outdoor unit right now is pulling 3 amps. Just barely running. And that's about the amps you're going to see, and it actually will stage itself down even lower in the summertime. So summertime gets here and you might not see the words cooling on the thermostat. You may see the words dehumidifying. when you see those words dehumidifying, this thing is running even lower than first stage. So I'm gonna go to the thermostat and I'm gonna try to get it to run third stage so we can see what it would be running realistically just about all the time, and we'll go from there. All right. All right, so with that Bryant Evolution system, this is your thermostat slash control system right here. All right, this thing had been running for 20 minutes and it went from 72 to 74. Yeah. See the words heat pump heating right there. This is Wi-Fi controllable. You can control it from your phone. I do have it on 74. Now, what stage is it running? Right now, it's going up to second stage. So it was running first stage. We were seeing it, and I can hear it speeding up. I can hear the fan out there speeding up a little bit. I'm gonna try to see if I can get it to stay in third stage. I mean, I can, but I would prefer it to do it by itself instead of me having to lock it in third stage. Us technicians, we know how to lock it in a certain stage, but that would actually shut it down and I'd have to wait. So, all right, fourth stage. And let me see here. Do I want it to run? It looks like it's either going to run second or fourth. It doesn't want to run third stage right now. I'm going to make you run third stage. Another thing that's important before I get into this is the startup amps of the unit. This one does not do that power surge thing like I said. You know how it flickers the lights? So right now, as you can see, the system's only pulling 1 amp because the board is getting ready to start up. All right. All right, for us technicians out there, those 2 lights right there are the most important lights. You just heard it click. In a minute, one of those lights is going to start flashing, and that's going to represent the variable operation mode. There it goes. All right. Every time the unit starts up, it does that dance. Again, that's a variable speed fan motor. You've got a variable speed compressor, and you've got a variable speed indoor motor too. So, .9 amps, 4 amps. It is speeding up, so the amps are going to go up a little bit. That's 6.06 amps right now. All right, it's speeding up. I think its target stage is 4th stage right now, the last time I just checked. Even when it's staging up, you can barely hear the thing. So yes, right now, like I said, it's running 3rd, 4th stage right now, picking heat up from outside, dumping it inside. Whereas in the summertime, this is going to be the line that's cold, the big one. This is going to be the line that's warm, all right? It's reversed now because we're trying to pick heat up from outside and dump it inside. So now this is the hot one. I'm not gonna say that's the cold one, but that's the one that's not hot. I mean, it's not hot. So that line right there, especially on an inverter system, oh, it's gonna be hot. We're running 4th stage right now, pulling 9.3 amps. So I think that's pretty darn good for a 3-ton system with a compressor. Check this out. Check this out. This compressor in this unit is able to spin up to 5,000 RPMs, whereas a single stage can only spin about 800 to 1,500. I mean, 9 amps and spinning 3 to 5,000 RPMs. It spins 5,000 at its highest stage. Middle stage, it's probably spinning about 3,500 RPMs or something like that. So the faster a compressor is spinning, if you take a single stage compressor and you try to spin it that fast, you're going to be pulling 30, 40 amps. I'm not even joking. Those single stages can't do that. And the reason you think 9 amps is a lot of amps for an inverter, it's not, because it's able to move heat in whatever direction you want it to a lot more efficient and a lot faster. So, and it's able to pull more moisture out too, because with that variable capacitance, these type of units actually run more than a single stage, but they pull less amps and they accomplish more work. So the thing is, a unit that when it cycles on and off and on and off and on and off, you know what I'm saying? Even though you have an inverter, that's not good for your power bill. That's not good for the inverter. So what they do is, instead of turning all the way off, they stage themselves down so low that they're just maintaining. And you saw 2, 3, 4 amps at first stage, you know, close to 6 amps in the second and third stages. You know, pulling that type of amp draw, that's less than a refrigerator, and you're maintaining. And what that does is that eliminates the cold spots in the house that, if you had a single stage, would cause the unit to have to cycle on and off, on and off, on and off. And that's what's spiking your power bill. It cycles off and it loses so much ground that when it comes on, it has to call for the auxiliary heat to come on, those strip heaters come on, those things. 3 tons, once you get to 3 tons, the strip heaters get to be between 10 and 15 kilowatts. More than likely, you're going to see 10. 10 kilowatts, it's every 5 kilowatts pulls 20 amps on the strip heater. So if you've got a 10 kilowatt, that's 40 to 45 amps. That's pulling triple what a compressor would even pull. So when you've got something that can spin 5,000 RPMs, not only are you pulling heat off of the outside and dumping it inside, the compressor itself is making its own heat. Now you're pulling heat off the compressor. So you're going to get air inside the house a whole lot warmer than you would on a single stage unit. Because, I mean, if 1,500 RPMs ain't enough, well, it's going to stage up to 2,000, stage up to 3,000, stage up to 5,000 RPMs. And it'll only stay in those stages for just a few minutes, and then it goes back down. And you'll hear it sometimes go up and down and up and down. But more primarily, it will stay in the mid stage to the lower stage, from what I have seen. I mean, right now I'm standing out here, it's staying near 39 degrees, and my fingers are about to fall off. This thing ain't even running 5th stage right now. It's 74 degrees in my house, and it has not called for my backup heat to come on in the last 24 hours. You know, it came on one time last night, and that was because it went into defrost mode. So that's the only, and my backup heat is gas, so I'm not pulling amps when I pull in, you know, when it calls for backup heat. But that is the Bryant Evolution. Or how, I guess they call it the Observer or something like that. But it's all the same thing. We're sitting at about 10 amps right now, and this thing's just carrying on, minding its business, you know, not making the power company angry. I'm gonna put the door back on, and you know, this is what the advantage of having a inverter heat pump is. I'm gonna go inside and I'm gonna stick the meter in the vent, and we're gonna see what type of heat this thing's actually kicking out without backup heat. All right, so it is 73 in here. The general rule is 15 to 20 degrees difference is good. I have seen that heat pump get 25 degrees difference sometimes. It just depends. You know, it's 39 degrees outside right now. That thing is running 4th stage. It's not even running its highest stage right now. And it's throwing out air close to 95 degrees. So, 94 degrees, right? That's how warm it's blowing. I'm gonna get it close to the middle. 94 degrees. That's without backup heat. That's without any assistance. I'm gonna go crank that thing up to 5th stage, and we're gonna see what this thing can really do. Yeah, 40 degrees outside. 4th stage. Watch this. One more. I just heard the fan speed up too. So on a system like this, variable speed, when you speed it up or when you turn the temperature up or down, the entire system reacts. Now, in this case, I've actually got it locked in the heat pump mode because my system that I put in, I didn't go back with a straight AC. I went with a dual fuel. So therefore, if I had it in system and control mode, and I'll show you. This screen right here, if you have a dual fuel, you would go here, 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 and there. Heat pump only. If I keep this thing in the system and control mode, it's going to go into gas heating mode. That's just what it's going to do because it's more than it's a 2 or more degree gap. But the reason I have it locked in heat pump mode is because what'll happen is it'll use the gas heat to get it to the temperature, and then it knocks out the gas heat and it'll use the heat pump just to maintain the temperature. On days where it's really cold, like last night, it got into the 20s last night. What this thing did is it would almost, it's like it would give, it's almost like it was relaying back and forth and back and forth. That's better than sitting there burning gas the entire night and cycling the gas on and off. Now with this type of system that I have, the dual fuel, it's a 2-stage gas furnace. So my gas furnace is a 2-burner, 50,000 BTU. I had a 4-burner, but I took that out because I have another source of heat. I don't need all that. And the thing is, when you've got a gas furnace, you don't want it to be sized to the point where it heats the house up too fast. Nothing can compete with the heat of a fire. That's the thing. We're blowing air out almost at 96 degrees. Might as well say 96. Might as well say 96. I mean, this thing is literally, and I'm standing way up here, and I can feel heat way up here because the indoor fan is variable speed. And when you have a variable speed fan motor, it is able to, it's probably going to blow harder than the unit that you took out. So I just bumped it back down to 74. I put it back in system and control mode, which means it would dictate whether it needs to run gas or heat pump. The heat pump's still holding on, and it just went down to 2nd stage. So I can go in right now and look, it's running 2nd stage. I mean, it's 39 degrees outside right now. It's in 2nd stage, 96 degrees in 2nd stage, and it's 74 in here. That's an over 20-degree gap. I mean, that is insane. If you ask me or any technician out there who's been doing this, the advantages of having an inverter heat pump over a single-stage heat pump, the words that are going to come out of their mouth are these words here. First thing is, they're a little bit more expensive than a, let me put this right back in there. They're a little bit more expensive than a traditional system. But if you don't ask, you'll never be educated on it. I mean, when you want your system replaced, you don't want to just replace with exactly with what you just got. If you're going to spend thousands of dollars to have this thing replaced and your power bill remains the same, or it only goes down by $20 or $30, that thing's going to, by the time it pays you back, it's going to be time to replace it again. Something like this will pay you back within the first 2 years. The first 2 years. Especially, look, let me tell you something. For anybody that's got gas heat out there, do not convert to a heat pump. Go dual fuel. Because if you convert to a heat pump, you got to change the furnaces. Gas furnaces run off 120 volts. The heat pump or the outdoor unit runs off of 240, whether it's a heat pump or a straight AC. If you convert to a dual fuel instead of converting to a heat pump, the only difference is the outdoor unit. And maybe the type of thermostat you get. But Bryant in particular, this Connex controller works with a straight AC or a heat pump or a dual fuel. That's how it works. I mean, those chips that I talked about earlier in the video, they tell the thermostat exactly what it's being hooked up to. It communicates. It tells the Connex controller, look, my outdoor unit is a heat pump. So I'm going to need you to recognize that, and we're going to integrate that, and we're going to optimize the operation of this system with the gas integration. So, and let me tell you something, the two will never run at the same time. If they do, it's because it's in defrost. So It never runs heat pump and gas heat. You will see HP plus gas heating on this Connex controller, but you look outside and you'll see steam coming off that thing and the fan's not turning and you won't be able to even hear it. So it's because it's defrost. And I kid you not, these things have I timed the defrost cycle. The defrost cycle doesn't even last longer than a minute and a half. It doesn't matter how cold it is. That thing defrosts so fast. I mean, the older units, they sit out there and they sit out there and they'll defrost and they'll defrost and they'll defrost and they'll partially defrost. You'll still see that ring of ice sitting around that thing. I mean, because the thing is, those units are not efficient enough to defrost that fast. And the board only allows it to stay in defrost for so long. So if it hadn't defrosted all the way, it's going to go right back into heat mode. And then that sensor is going to say, well, look, we need to defrost again. And it's going to defrost again. And then it ain't going to defrost. I mean, that's just the way they work. I have sat there and I have worked on so many heat pumps. And I'll sit there and I'll defrost that thing. And it won't defrost all the way. The Bryant Evolution, that thing, you can sit there and you can watch the ice go off of it within seconds. Like, literally, I sat there and I watched that thing and it's like it disappeared, literally. So, again, efficiency. You've got, like I said, that compressor is spinning 5,000 RPMs. 5,000 RPMs on an engine, it generates a lot of heat. What do you think it does for a compressor that's got refrigerant flowing through it? Let me tell you something. Refrigerant is a different animal, especially with this new R410A. Yeah, it definitely takes that refrigerant and it operates different than a single stage unit. I mean, I highly advise you, if you're going to replace your heating and air conditioning system, get something, because let me tell you something. What's going to happen when your gas gets cut off because they're working on the gas line or because you forgot to pay a gas bill? Or what's going to happen if your electricity gets cut off? Well, let me tell you something. Well, this is me because I can do this. If my electricity got cut off, I can plug a generator up to my unit and it'll still work because I can run it off the gas. So, I mean, I can go up under that house, wire up me an extension cord to it, and plug it up to a generator and I'll still have heat. I mean, I'm just saying, you know. Yes. Again, to recap, you replace your heating and air conditioning system, you talk to somebody, you say, hey, because let me tell you something, 9 times out of 10, when you have your system replaced, the guy is going to put you in what he standardly goes with, you know. And I will say, they do not yet have, if you have a package unit, they don't yet have inverter package units. But this is a split heat pump, split dual fuel system I got at my house. So if you, like I said, if you've got a gas furnace and you've got a straight AC, it is going to beseech you and benefit you to go dual fuel. Because if you're paying $200 a month for a gas bill, look, let me tell you something. My gas bill went from close to $200 a month down to $140 in this house. And this is a 3-bedroom, 2-bathroom house, 2 full bathroom house, 1,400 square foot. And gas bill was $140. It's 2-stage. My electric bill, my usage on my electric bill, it sits around $130. And if I feel like I don't want to pay my gas bill, I just switch it over to heat pump. If the electric bill starts getting higher than what I usually target it at, well, I will just lock it in gas heat mode. I mean, that's the thing. You know, I don't know. I mean, and it's off right now, and it's 38 degrees outside. The temperature has been steadily dropping the entire time this video has been being made. So, I mean, it's 39 degrees outside, and my unit has shut completely off. The gas isn't running. It's 74 degrees in here. The gas isn't running. The heat pump isn't running. You can see right now, it just cut itself back on. Like I said, when this thing is maintaining 74 degrees is where I keep it. It is on. It's running 5th stage. All right. I mean, it's running 1st stage, shall I say. So yes, those are the advantages of owning a inverter heat pump. Like I said, I focus on the Bryant because this is the one at my house that I put in. There's reasons why I did not choose a single stage. I mean, I could have just chose a single stage, but because I do this every day and I know how these systems operate, I'm gonna go down there so we can see exactly how quiet it is. Again, like I said, you hear this thing? You used to hearing that, like I said, you used to hearing that loud noise, but again, you know, this is, oh, it's cold. Oh, I can't even hear. But yeah, this is the Bryant Evolution 18 SEER heat pump. We kind of learned a little bit about how heat pumps work and the advantages of going with something more beneficial and more efficient. There's reasons why I did not choose a single stage unit, because I do this every day. I know the advantages, I know how to work on these things, and I know the benefits of, you know, it's just one of those things. Do you go to the car dealership and buy the cheapest thing? Like, you know, you go to a Ford dealership and you've got $50,000 to spend on the car, why would you buy a Ford Fiesta? You know, the Ford Fiesta is not engineered the same and as strong and rugged and capable as a Ford Explorer ST or a Ford Edge ST or a Ford Mustang. Something that you're going to use to go fast or to tow something that you can take off road, that you can beat on a little bit and it still drive like it's supposed to. You take a Fiesta off road and you see how long it lasts. So again, I want y'all to just, you know, think about that and talk to you guys. You know, when they come to your house, don't just let them sell you something just so they can hurry up and get out of there and leave you with some piece of junk that's not going to last you but 2 to 3 to 5 years before you start having problems and you wonder why your power bill hadn't changed, and in fact it might have went up. You know, get something higher up. You know, it's going to benefit you, that you can have more control over and be more comfortable with. Again, this is Malik, and I hope y'all stay warm out there, stay comfortable, because we've got an evolution of weather changes coming to you in the South. One day it's 40, the next day it's 80. Uh-oh, I think we're about to go in the defrost, boys. It's slowing down. It's got ice all over it, dude. I can see the ice in it. Yep, I knew it. Dude, the fan blade has ice on it, dude. It's defrosting right now, and you can't even hear it. Thing's so quiet. Dude, and all the ice is already gone. It is on and defrosting right now, bro. Look at the steam coming off of it. It is steaming, bro. God. Y'all can't see it, but bro, it is steaming, dog. Oh. Look at that steam. Yeah, boy. Yes, sir.